And here we are again for another lesson of algebra. This is John Lundquist, and this is Algebra 2, Lesson 3-6, Graphing Absolute Value Inequalities. And just a review on absolute value. The absolute value of 5 is 5. The absolute value of negative 5 is 5. So you notice you always get a positive. It's really defined as a distance. So negative 5, which is here, negative 5 is 5 units away from 0, and positive 5, which is here, is also 5 units away. So it's a magnitude. It's a distance or a magnitude. Like negative 20 is a magnitude bigger than negative 15, right? It's bigger, it's more negatives, but we consider it less than. Consider negative 20 less than negative 15. It's a smaller number, but it's a bigger magnitude. It has more negatives than negative 15, but it's bigger. As opposed to positive numbers, which the magnitude and the number is also bigger. So you get more positive this way and more negative this way. So negative numbers have kind of like have a double meaning. The more negative something is, the more it's a bigger magnitude of negatives, but the more negative you go, the less the number is, the smaller the number is. So this I mentioned that it's very confusing. It's confusing to anybody that just looks at negative 20 and considers negative 20 less than negative 15. A number is bigger than 15, right? But it's a smaller number, but it's bigger magnitude. Okay, so since the absolute value of 5 is 5 and the absolute value of negative 5 is 5, then the absolute value of x, which is equal to 5, then means x has two values. It's plus and minus. You can say x is equal to 5 and negative 5. Or, as we in the mathematics world say, it's plus or minus 5. We like to do that. But, you could write this too. It doesn't matter. Okay. So let's look at the first problem here. So I got the absolute value of 2x minus 3 is greater than 7. So again, if you have the absolute value of x and it's equal to 5, well, that means this x has to be 5 or negative 5, right? It has to have two values. It takes on two things, 5 and negative 5. Well, it's the same thing here. If I say the absolute value of okay, so I go like the absolute value of 2x minus 3 is greater than 7. This thing here, this value has to be greater than 7 or less, or it has to be a negative greater than a negative 7, because this thing, if it was negative 8, this is negative 8, the absolute value of negative 8 is 8, right? So 8 would be greater than 7, because that's the magnitude thing again. So I have to have two equations. I have to set this thing equal to greater than 7, but because I'm going more of a magnitude issue, I have to say 2x. So I have this. This is 7 here. 2x minus 3 has to be less than negative 7. So I do two things. I flip the inequality and I negate this guy. In other words, I'm negating the right side. So in essence, I'm negating the inequality too. So to undo the negation, which I just did, I set the inequality less than. Or, you know, you can think about magnitude-wise. This has to be a greater negative to when its absolute value becomes positive. It has to be greater than a positive 7. Okay, so I'm going to add 3 to both sides. Now I just solve like a regular normal equation. I get 2x is greater than 7, 8, 9, 10. And I divide by 2, and I get x is greater than 5. Okay? Then here I'm going to add 3, and I get 2x is less than negative 4, right? Because 3 from negative 7 is negative 4. Divide by 2, and I get x is less than negative 2. So I get less than negative 2. So let me do it in red. Less than negative 2. So it's going to go like that. And it's going to be greater than 5. Here's 5. And here we go. So notice that if you have a greater than, it's kind of a spread out thing. It kind of does this. This is a typical greater than. Okay, so then I have the next one. I have the square root, not the square root, the absolute value of 2n over negative 5 is greater than or equal to negative 4. Okay, so now I'm going to, I'll rewrite it here, negative 2n absolute value over negative 5 is greater than or equal to negative 4. Okay, so I have to multiply this. I want to get this absolute value by itself before I can actually split it into a positive and negative. So I'm going to multiply both sides by negative 5. Okay, so there's a rule involved here. When I multiply or divide an inequality by a negative, I am in essence negating this inequality. So I have to flip it. So I have to flip the inequality the minute I multiply or divide by a negative. So I get the square root of, the absolute value of 2n is now 2 negatives make a positive over here. And that'd be 20, right? So then, now I split. Then I get 2n is less than or equal to 20, and 2n is greater than or equal to negative 20, because I have to get a magnitude issue. I have to make sure that when I negate this guy, I flip the inequality. 2 things. Divide by 2 here, 2. I get n is less than or equal to 10, and n is greater than or equal to negative 10. So I get greater than or equal to negative 10, and less than or equal to 10. So this is going to be shaded in. And notice I have a bridge here. Now, this kind of contradicts my rule of greater than spreading out. That's because I have a negative here. That's because I have this. That's because I flipped. I had to undo this by multiply by a negative. So it doesn't always hold this rule. Okay, so last one here. We have negative. Should I use a different color? Purple. Okay, so the absolute value of negative 3x plus 4 is less than 34. Okay, so I'm going to minus 4 from both sides. I'm going to do that first because I want to get the absolute value by itself. And then minusing 4 does not flip the inequality, only multiplying or dividing. And I get 30. Now I do my split. So I get negative 3x is less than 30, and negative 3x is greater than negative 30. Okay, because I have to, because I had to, you know, this isn't, it doesn't look like a negative 30, does it? Let me just erase that again. Let me try it again. I'm doing black. So it's negative 3x is not less than, greater than negative 30. How's that? A little better. Okay, so I divide by negative 3, divide by negative 3. When I divide by negative 3, I have to flip the inequality because I just divide by negative. I get x, and I get negative 10. I divide by negative 3, divide by negative 3. I flip the inequality again. This is x is less than 10. So I get x is greater than 10, and x is less than 10. Oh, I get another 10. And I get that. Okay, that's it. Good luck. If you have any questions, let me know.